Okay, so let's get started. So sampling part 2. So in this lecture, we will be talking about the last topic, that is Gibbs sampling. So we have already covered uh, prior sampling, rejection sampling, likelihood weighting, right? So this is the last topic that we have in this entire uncertainty module. Okay, so let's talk about it. What is Gibbs sampling? So we know that in case of likelihood weighting, if you remember, in case of likelihood weighting, there is one problem, right? And what is that problem? The problem is that the evidence that you are considering will have the impact on the downstream variable. Yes or no? Will have the impact on the downstream variable, not on the upstream variable. If you remember, in the last lecture we have discussed this. So for that reason, now we are going to consider the next type of sampling that we have, which is nothing but Gibbs sampling. Okay, so in case of this Markov chain Monte Carlo, basically this is another type of sampling, but in this Markov chain Monte Carlo sampling, we have a specific case which we call it as Gibbs sampling. Okay, so that is important from your exam point of view, and we will be discussing that now. So let's understand what is the idea behind this Markov chain Monte Carlo. So the idea is very simple. Instead of sampling from scratch, like if you like you have seen in the previous lecture, when we were talking about the sampling part, so whether it is prior sampling, rejection sampling, so what we do, we have a distribution, and what we do, we basically you can say extract some samples, and using those samples we try to find out the the you can say, given what will be the probability. So all those things we try to answer using those samples only, right? Instead of using the entire distribution. That is the idea of sampling, using sampling in case of this. So instead of sampling from scratch, create samples that are each like the last one. Okay, you will understand what is the meaning behind it with this diagram. So what is the procedure? Procedure is resample one variable at a time. So in this Markov chain Monte Carlo, it says that you have to resample one variable at a time. Okay, for example, let's say conditioned on all the rest but keep evidence fixed. Let's understand this example. So in this example, let's say you are trying to find out probability of B given C. So what is the evidence here? The evidence is C here, right? Now if you consider this particular Markov chain, so you will find it out here, or let's say this is a particular sample that you have. So carefully see this. What do you have here? Plus B plus A plus C. So at a time, as it is mentioned, at a time you are going to resample one variable. Okay, so let's say as of now you are considering this one variable, and let's say the value you are considering is plus B. So all these are A, B, C, all these are this Boolean random variables. Okay, that means they can have two values, either positive or negative, or you can say true or false. So as of now we are just considering one variable, so let's say it is plus B, right? And here it is plus A and plus C. Fine. So now if you consider the next one, so once you, let's understand in this way, once you select one particular random variable, and it is randomly, you can select any one variable, let's say you select B. Now you conditioned on all the rest, so like A and C. So you conditioned all on all the rest. He's blocked. How he is blocked? Okay, uh, we can ask him to clear his cache. Okay, this will be an interruption to the class. Wait for a minute. Ask him to log in now. Let's wait for 1 minute so that he can also join. Okay, now he has joined. Is it fine now, Manjunath? Audible and visible clearly? Hi, Manjunath. Okay. So let me repeat once again for Manjunath as well, just from now on, from this slide onwards. So far we have seen what is prior sampling, rejection sampling, and likelihood weighting in the previous lecture. Now we are talking about Gibbs sampling. Gibbs sampling is a specific case of Markov chain Monte Carlo. Okay. So what is the idea behind this? Instead of sampling from scratch, we create samples that are each like the last one. That means how the last sample we have, it is going to be similar to that. It is going to be similar to that or likely to that. I mean, almost similar to that, right? So we create that type of samples here. Fine. Now, what is the procedure? The procedure is you resample one variable at a time. So you can pick, like, let's say you have three variables here, random Boolean variables, A, B, C. Out of all these three, you just pick one variable randomly, right? And then you just resample that one variable. When I say resample that one variable, what does that mean? You conditioned on all the rest of the variables, and whatever is the evidence. Can I say here the evidence is C? Yes or no? The evidence is C here. So you fix the evidence. The evidence is going to be fixed always, right? But you pick any one variable, and for the remaining one you conditioned on that. That will make more sense as you follow. You will understand much more when we are going to see the questions also. Just follow as of now. So what we are doing, let's say we have selected B, right? And the value is plus B here. The evidence is C here, and let's say you are conditioning on the remaining variables, that is A. Fine. Similarly here also, you can see now, if you compare this one and if you compare this one, can you see that there is only one variable change? What do I mean by that? If you see here, plus A is here, plus A is also present over here. Plus C is here, plus C is also present over here. So you can see that the only difference you have is here it is plus B and here it is minus B, right? So that is the only difference you have. Clear? So that is the reason why it was saying that you create the samples that are each like the last one. Now, similarly, if you compare this one and this one, so here now you have picked A as the variable which you are going to resample. So here it is plus A, and here now it is minus A. This plus C, that is fixed, and here it is minus B and minus B. So there is not much change. If there is a change, that is going to be only for one variable. So only one variable change will be there. Is this clear so far? Any doubt, anyone? Why we are doing it and what is the reason, you will understand in some time. Okay, just follow as of now. Like, we are just talking about the procedure that we have. So that is the standard procedure, we have to follow it. Okay, so what are the properties? Now samples are not independent. In fact, they are nearly identical. So for example, if I write some samples like this, let's say maybe let's say plus B plus A, let's say minus C, and then I write like this, plus B minus A plus C. Now if you compare these two, sample, can I say they are independent, completely independent? They are not identical or nearly identical. Why? Because there is a lot of difference here. Here it is plus A, here it is minus A, here it is minus C, here it is plus C. So you can see more than for more than one variable, they are changing, right? So here A is also changing from plus A to minus A, and to minus from minus C to plus C. So these are independent, you can say. These are independent samples. So the same thing is mentioned over here also. Now samples are not independent. Why? Because now in this scenario, what is happening? Now in the scenario, let's say it is plus B, plus A, minus C, and now it is plus B, let's say minus A, minus C. Now if you see, only one variable is changing its value, right? From one sample to another sample. So this is what? This is, you can say, nearly identical. These are nearly identical. And that is the idea behind using this Markov chain Monte Carlo. And as I told you, Gibbs sampling is a specific case of this. Fine. So now samples are not independent. In fact, they are nearly identical, but sample averages are still consistent estimators. So if you take the average of it, still it will you will be able to estimate it properly. So what is the point here? Now the point is both upstream and downstream variables condition on evidence. If you are doing this, so based on the evidence that you are fixing, so as you can see here, keep the evidence fixed. So once you fix the evidence, now you are considering both the upstream variables as well as downstream variables. Whereas in case of this likelihood weighting, you are only considering the downstream variables, not the upstream variables for a given evidence. Is this clear? Any doubt, anyone? So now we are going to consider a specific case of Monte Carlo, Markov chain Monte Carlo, that is a Gibbs sampling, and this is important and you will understand. A quick glance. I have given the quick glance only. Manjunath, you have not missed anything. I started from this slide only. Okay, you have not missed anything. Fine. No, just follow, you will understand more and more. So for particular, no, something is not behind. I mean, you have started from the first slide only. Okay. So for Gibbs sampling, what is the procedure? The procedure is keep track of a full instantiation. That means from x1 to xn, all the random variables. Start with an arbitrary instantiation consistent with the evidence. Sample one variable at a time, conditioned on all the rest. Same thing is mentioned over here, but keep evidence fixed. Keep repeating this for a longer time, or you can say for multiple iterations. Right? With example, you will understand more. So let's just read it what it says. And what is the property? In the limit of repeating this infinitely many times, if you repeat this procedure infinitely many times, the resulting sample is coming from the correct distribution. So whatever resulting sample you will be having, that will indicate the correct distribution. And as I told you here, both upstream and downstream variables condition on the evidence, which was not the case in case of likelihood weighting, right? As it is also mentioned, in contrast, likelihood weighting only conditions on upstream evidence. And hence, weights obtained in likelihood weighting can sometimes be very small, right? Because what was happening when you are talking about likelihood weighting, let's say you have B here, C here, maybe A here, something like this. And let's say you have D here. Now, this was the issue, right? So here, this, let's say maybe the evidence is B. So if you are calculating this probability of A given B and C. So in this case, what was happening? So this D is independent, right? If this is the evidence you have, let's say you have the evidence only B, or let's say you have evidence both B and C, then this D is independent, still independent, right? So this particular random variable, right, it is depending upon, or you can say it is, acting according to the evidence, but the effect of the evidence is not on the upstream variables. So this is what it is saying, which we have already discussed in the previous lecture as well. So sum of weights over all samples is indicative of how many effective samples were obtained. So want high weight. Now let's understand through one example, and through this example, you will be able to get the entire idea of what and how we are doing this Gibbs sampling. So carefully understand this. So let's say you are having this, you want to find out, let's say this probability of S given plus R. So this is your evidence. This is your evidence, correct? This plus R is your evidence. Now, what is the first step? The first step is very simple. You fix the evidence as it was mentioned in the procedure. You fix the evidence. And what is the evidence? R is equal to plus R. So you can see here, you have fixed it. Now you are not going to change from plus R to minus R. Okay, this is one thing. And this is the evidence you are going to consider. What is the step 2? Step 2 is initialize other variables, and you can do it randomly. So now it's up to you. Like you can see you have other variables as C, S, W. Now it's up to you. You can pick any combination, maybe plus C, plus S, minus W, or maybe plus S, plus W, minus C, whatever you want, you can pick randomly. In this scenario, they have picked this randomly, that this green represents it is plus C. And red represents they have selected as minus S and minus W. Is this clear? So they have initialized the other variables also randomly. What is step 3? Step 3 is very simple. You have to choose a non-evidence variable X. So as I told you in this also, that you have to pick. Start with arbitrary instantiation that we have done and sample one variable at a time. So you can pick any one non-evidence variable X. Clear? And what you have to do? You resample X from probability of X given all other variables. This is how you are going to do it, right? So now carefully see this. Let's say you pick S as a non-evidence variable. Let's say you have picked S as a non-evidence variable for the first time. Okay. So if you have picked this one, so can I say it now? You are going to find this. You are going to resample this X. So probability of S given it is plus C minus W plus R. So this is what you are going to sample from. Is this clear so far? Once you have done it, after this one, you can pick other non-evidence variable. Let's say this time you are picking C. So the same thing you have to do, resample C this time, right? So it is going to be what? Probability of sample from probability of C given plus S minus W plus R. Fine. And the same thing you have to continue for all other non-evidence variable. Like here in this case, you have picked W. So it is going to be like this. Is this clear? And you have to keep on repeating until you cover all the non-evidence variables. And you can do it many times also. Is this clear? How you are doing resampling over non-evidence variables? Is this clear to all of you? So when I say sample from, when you are writing it here, sample from this, what does that mean? That simply means you know this, how to find it. So this is the scenario that let's say we are considering, the first scenario where you are selecting S as a non-evidence variable. So it is going to be probability of S given plus C plus R minus W. You know that you can write it like this, correct? Conditional probability. You can write it like this. So in the denominator, it is nothing but the total probability. So it is going to be summation over S, right? So because this is given to you, so now you can have all the values of S. So summation over S, and the numerator, you can write it as this is going to be a joint distribution. Yes or no? And you know how to write a joint distribution. You have this graphical model here. So you can simply say it is going to be probability of plus C multiply probability of S given C plus C, you can say, right? Multiply probability of plus R given plus C, right? And multiply probability of minus W given plus S plus R. Or you can simply write S also. I mean, yeah, not plus S, it should be S, because here we are selecting this as a non-evidence variable or on which we are doing resampling. So it should be S. Is this clear? So that's what we have written in the numerator. You know this, how to write this expression, how to write this joint probability distribution using this graphical model. So now if you see here, in the denominator, you are taking summation over S. That means whatever terms which are not dependent on S, you can take it out. Yes, definitely we can take it out. So probability of plus C, we can take it out. Probability of plus R given plus C, you can take it out. And that will cancel out with the numerator. So this will cancel out, right? And what else? This will also get cancelled. And now you have just this term remaining. So probability of F, probability of S given plus C into probability of minus W given S and plus R, and divided by summation over this. Is this clear so far? Do you have any doubt? Anyone having any doubt? So this is how we are doing a resampling over one at a time. We are just picking one variable, non-evidence one variable, and over that we are doing the resampling. Similarly, you can select C also. Similarly, you can select W also, right? So the same thing we have to follow. So many things cancel out, only CPTs with S remain. And more generally, only CPTs that have resampled variable, that means here in this case it is S, need to be considered and joined together. Clear? So from this, you understood the idea, right? What we are doing. From this Gibbs sampling, you can expect a very simple question, which we are also going to cover. I have included one question, one foreign university question, that is from, I think, Southern Illinois University. And that is a complete question for the sampling. Like you have a question on prior sampling, rejection sampling, likelihood weighting, and Gibbs sampling. So that will give you the entire, a revision also for the previous sampling methods that we have covered. And you will understand that what type of questions you can expect in the GATE exam from this entire sampling topic, that is approximate inference. Okay. And now we have that question. So is this question visible to you? So that is only your Gibbs sampling, nothing else. Is this clear? If it is clear, then we can proceed towards the questions. Yes, Manjunath, Chandana, Abhas, Gurdeep. Any doubt, anyone? Okay. Just let me know, is this question visible to all of you? Visible, na? Okay, fine. Somewhat. Okay. Yeah, if you carefully observe, you will be able to see what is the values we have, right? Okay, so this is the entire one question, and it is having many parts. Okay, so assume the following Bayesian network and the corresponding distributions over the variables in the Bayesian network. So this is the Bayesian network given to you along with, so basically you can say, when I say Bayesian network, that means you have the graph along with the CPTs, conditional probability tables given to you. Fine. Now you are given the following samples. So as I told you in the previous class also, that they will provide you the samples. Yes or no? They will provide you the samples in the questions. So all these are the samples given to you. Total 8 samples are there. Can you try to answer this question? First part. Assume that these samples came from performing prior sampling. Now calculate the sample estimate of probability of plus C. Can you answer this? Anyone? I hope you remember what is prior sampling. So you simply have to find out probability of plus C. You simply have to estimate, because we are basically approximating, right? 0.8. You can also tell me in the fraction, Abhas. You can also tell the fraction value. Number of plus S plus C divided by total samples. What is the answer? Tell me the answer. 3/5. Are you sure? Total samples are 8. That is there on your slide. Five by 8. Okay. So let's see it here, everyone. Carefully see this. Probability of plus C will be what? Divide. See, in the denominator, you will be having total number of samples. I told you whatever samples is given to you, you have to consider them. Right? So can I say total 8 samples are given to you? Yes, 4 plus 4, that is 8 samples given to you. And what about the numerator part? So you are going to consider those, you are going to select those samples in which the value of C is plus C. So if you see carefully, 1, 2, 3, and 4, and 5. So total 5 samples are there. Total 5 samples are there, which is having the value of C as plus C. So total, the value will be 5 by 8. Is this clear? Only these type of questions you can expect if they are going to ask any question from prior sampling. So it will be like this. And very simple question. Obviously, it is going to be 1 mark question if they ask. Okay. Is it clear? If it is clear, then try to answer the second one also. Now we will estimate probability of what we are going to estimate, probability of plus C given plus A minus D. Above, clearly cross out the samples that would not be used when doing rejection sampling. I told you when we have the condition, when we have the evidence given, obviously prior sampling cannot be used. You have to use the rejection sampling in that case. And it is also mentioned here clearly that you have to use rejection sampling for this task. Write down the sample estimate of this probability of plus C given plus A minus D. Yes, anybody wants to answer carefully? I'm giving you some time, 30 to 45 seconds. Tell me what should be the answer. What we do in rejection sampling? Anyone else getting the answer? Remove samples which do not match with the evidence. Very good. That is correct, Chandana. So if you remove the samples, how many samples will be remaining? Once you remove those samples, 3 samples will be remaining, right? Out of 8, 3 samples will be remaining that you can see which are not, encircled, or you can say which are not having the, rectangle on it, or you can say the unselected samples. So those are that samples which are having plus A minus D, plus A minus D, plus A minus D. So these are the 3 samples that we have. And now we have to see, because we are finding the probability of plus C given this evidence. So plus C, in which cases we have plus C? We have in this one, plus C is present over here, plus C is present over here. So it is going to be 2 by 3. Is this clear? This type of question you can expect from rejection sampling. Shall we proceed now? Anyone having any doubt in this? Okay. Now let's try it. So as you can see, the answers are also given here. 5 by 8 and 2 by 3. Wouldn't there be conditional questions in prior? No. Manjunath, you are asking the same question that you asked in the last lecture. I told you in the prior sampling, what do we mean by prior sampling? What do we mean by prior word? Just tell me this. Simple. So how can you have the questions which are having conditional equations or conditions? Obviously you cannot use, right? Life is tough sometimes. Don't worry. If you are following these lectures properly, your life will be easy in the GATE exam also. So 5 by 8, as you can see the answers, I hope it is visible, 2 by 3. Fine. Now the next question. So the question is same, like these CPTs are, exactly same. Now we have these parts B, C, D. Let's try to answer these parts. And I want you to solve these so that you can get some practice. I have already solved these type of questions. Fine. So now it is based on likelihood weighting. Using likelihood weighting sampling to estimate probability of minus A given plus B minus D. The following samples were obtained. So we have used this likelihood weighting sampling and following samples are obtained. These are the 4 samples. Now we have to find the weight of each sample in the corresponding row. This type of question we have already solved in the last class. Now I want you to solve at least one. Let's say solve first part, or remaining part you can take it as a homework also. But first now solve the first part. Okay. So find out, let's say I'm naming it as W1. What is the evidence? Yeah, I'm showing you the CPTs. What is the evidence and graph also? But before that, just tell me what is the evidence quickly, because you have to first focus on the evidence here. The evidence is plus B minus D, correct? Have you written the entire sample in your notebook? It is minus A plus B plus C minus D. Now I'm going to show you the CPT. Okay, write it, Chandana. Write the entire sample, first sample, minus A plus B plus C minus D. Okay, now start solving this. And let me know what should be the answer. What would be the answer? Okay, Manjunath is getting 1 by 3. Okay, we'll see. What about others? This question you can do orally also, like you don't have to write everything, but yeah, I would suggest you to write definitely, just to avoid any mistake in the exam also. Okay, 5 by 18. Okay, 2 students are getting 5 by 18. What about others, Abhas and Chandana? Five by 18 is the correct answer. Very good. Those who have answered this. So what we have to do, how we can find, can I say, you can write like this: probability of, based on the graph, probability of minus A multiply probability of plus B given plus A, minus A, into probability of plus C given plus B into probability of minus D given plus C. Yes or no? Correct, right? Okay. So now you know this value will be 1 because it is not depending upon the evidence. These are the evidence. Plus B and minus D. So plus B and minus D is not present over here. But if you carefully observe, here you have the evidence, part of the evidence you can say, definitely. So plus B is there. So now you have to find the value using the CPTs. Plus B given minus A. Plus B given minus A. So it should be 1 by 3. It should be 1 by 3. What about this plus C given plus B? Again, there is no evidence here over here because evidence is having plus B minus D, so it should be 1. And minus D given plus C. Again, evidence is there. Minus D, evidence is there. So minus D given plus C. Minus D given plus C, that is nothing but 5 by 6. So the answer would be 5 by 18. Is this clear to all of you? Any doubt, anyone? Can I give you these 3 questions as homework, or do you want to solve right now? It's all up to you. Let me know. Homework or right now? These 3 samples, the weight of these 3 samples. Tell me quickly. Let's have it as a homework. Answers are already given on the next slide. You can verify once you solve it. Okay. Fine. Can you, okay. So now the third part also you can solve. Once you have find all the weighted samples. So once you have find the weights of all these samples, can you estimate this? That is simple. This type of question also we have solved. Yes or no? So you have to consider those samples where the evidence is plus B minus D. So if you see here plus B minus D in all the samples you have plus B minus D. That means you have to consider all. So in the numerator part, can I say it will be addition of all the samples? It will be addition of weights of all the samples. Yes. And in the numerator you will be having only minus A. So can I say for the first sample, that means W1 will be there and W4 will be there. So it should be what? It should be simply W1 plus W4 divided by W1 plus W2 plus W3 plus W4. Yes or no? This will give you the answer. Any doubt? Done? Fine. What about this part? Which query is better? Now let's try to answer this. You will be able, you can answer this question if you have understood it. What is likelihood weighting? Which query is better suited for likelihood weighting? Probability of D given A or probability of A given D? Justify your answer in 1 sentence. Think about it. I'm giving you some time. Carefully think about it and let me know. Which query is better to answer for likelihood weighting based on the graphical model we have? D given A or A given D? Manjunath, why you answered 2 times? In the GATE exam, you are not going to have the choice of answering the question multiple times, right? If D is positive, then we lose all samples. The answer is very simple. See, what we do in likelihood weighting. Sachin sir said to learn from mistakes. That is fine. So you should learn, definitely. Likelihood weight evidence given all those things. See, if I say you are trying to estimate. Basically, when I say which query is better, that means you are trying to estimate these. Gurdeep. Like in this scenario also, we are trying to estimate this, right? Our evidence is plus B minus D only, but we are trying to estimate this. So now which one is better? Can I say D given A is better? What do you think? Probability of D given A is better? Because based on the previous evidence, we can find out the probability of D. That will be much better if we are using likelihood weighting, right? If you see here, the answer is very simple that we have already seen. Carefully see this. Probability of D given A is better suited for likelihood weighted sampling. Why? The reason is very simple, because likelihood weighting conditions only on upstream evidence. Yes or no? You calculate. See, here it is, Gurdeep. Here it is not talking about how to calculate the weights. It is talking about if you have to estimate this. That is a procedure. That is a which whatever you are talking about, you are talking about this. Let's say if I say something like this, let's say maybe probability of X given Y, this Y is my evidence. I want to estimate this. I want to estimate this. To estimate this correctly or approximately, basically what we are doing, we are finding the weights of each sample we are finding out. And how we are finding the weights? We are finding the weights, like you said, probability of evidence given its parent. This is how we find the weights of each sample. But the question is asking about this thing. Which query is well suited to estimate if I'm using likelihood weighting? Is this clear? Fine. So that is the reason, as you know, that in case of likelihood weighting, conditions only on upstream evidence. So whichever upstream evidence, that means, as I told you here also, let me add one more slide. A, B, C, D. So if I'm talking about, let's say this is my upstream evidence, D will depend on this, but A is not depending on this. Is this clear? So if I ask you a simple thing again, probability of B given D is well suited or probability of D given B? Now tell me answer. Which is well suited for likelihood weighting? Which one is well suited for likelihood weighting? If this is the model given to you, graphical model, obviously probability of D given B. Is this clear? Because the upstream evidence condition, we are finding likelihood weighting based on this upstream evidence. Is this clear now? Any doubt, anyone? So that is the reason. And these are the answers. You can just verify later on. Okay, once you solve this. Okay, let's see the last question now. So that is based on Gibbs sampling. So far we have seen what kind of questions you can expect from the sampling topic. And I hope now you are feeling more confident that whatever question comes, you will be able to answer it. And this will be the pattern of the questions, if they are going to frame any question from sampling. It can be of 1 mark, it can be of 2 marks. So most probably, if they are going to ask question from likelihood weighting, 99% what I feel is it will be of 2 marks, because calculation is involved. You have to find all the weights and then you have to estimate. But if I talk about rejection sampling and prior sampling, 1 mark question is possible. Okay. Now let's see question based on Gibbs sampling, and this is also very easy question. I want you to try first. Recall that during Gibbs sampling, samples are generated through an iterative process. You know, we follow the iterative process, right? One by one, we select the non-evidence variable and we resample on it. Assume that only evidence that is available is A is plus A. This is the evidence that is available. So what we do in Gibbs sampling, we fix the evidence. Yes or no? Everyone, we fix the evidence. This is step 1. We fix the evidence, right? So here the evidence is plus A. Now clearly fill in the circles of the sequences below that could have been generated by the Gibbs sampling. Now you have to answer out of these 4 sequences, what are the sequences that are possible? This is kind of MSQ question. I want you to try first. Tell me, what are the sequences possible here out of 4? Think about it. Can you tell me which sequence is definitely not possible? Just by looking at it, you can find out that this is not possible. Focus on the step 1, fixing the evidence. Fixing the evidence. I'm giving you the hint. Exactly. Sequence 2 is not possible. Sequence 2 is not possible. Why? Because you have minus a. This cannot be possible because you are fixing the evidence. So sequence 2 is not possible here. Okay. What about other sequences now? In all other sequences, it is plus a only. What else we have to see? You have to see that I told you, right? When I was discussing that Monte Carlo Markov chain Monte Carlo, I told you that there is only one, as we are resampling over one variable, so there will be change for only one variable from one sequence to another, from one sample to another. Well, in third step, should I select a non-evidence node? Yes, for the third step, when we are repeating, right? We select a non-evidence variable. Like, let's say in our example, we picked first S. After that, we can pick any other random variable, let's say non-evidence random variable, let's say C, then W. When all are covered, then it is done. Clear? So here it is very simple, carefully see. Yes, but in our graph, yes, ask your doubt, Manjunath, completely, then I will answer this. Except everything is dependent. Except everything is dependent. Right. So you don't have to consider A. That's what I'm saying. Non-evidence variable only. That means here you can say BCD. Here you can say BCD. Is this clear? Okay. Now carefully see this, everyone. As I told you, that is the property that we are using. We are sampling over one variable at a time. So there should be only one variable change, right? Because we want the samples to be nearly identical, not independent completely, nearly identical, right? So carefully see this. Plus A is fixed. Now let's carefully observe this. Minus B minus C plus D. If you compare these two samples, can I say there is only one variable change or there is no change? Either there is no change or there is only one variable change. So nearly identical. So you can see these are identical. Yes or no? Similarly, if you compare these two, can I say there is only one change? Carefully observe. Minus C and plus C. Plus D same. Minus B same. So there is only one change. So can I say this sample can be generated or could have been generated by the Gibbs sampling? So sequence 1, that is correct. Sequence 2 already eliminated because it is minus A. We are fixing the evidence. So it is not possible. It is not possible. How they are same? Compare this now. Different now. Okay. Let's see sequence 3 now. Okay. Yeah, that is possible. That is fine. There is no issue. I told you that it should be nearly identical. If it is almost identical, that is also fine. Fine. So sequence 3 now. Carefully see this, whether it is possible or not. If you compare these two, minus D plus D, fine. Only one variable here. Minus C, that is same. That is same. If you see here, minus D, that is same. Minus C. So only B is changing. So yes, sequence 3 is also possible. What about sequence 4? 4 is not possible. Okay, let's see. So if you compare this, plus D, minus C, minus B, that is fine. If you compare these two, minus D, minus B plus B. So this is not possible. Sequence 4 is also not possible. Is this clear? So the answer is 1 and 3. Okay, so let's see here the explanation also given to you. Gibbs sampling updates one variable at a time and never change the evidence. Now this is important, as I told you. Clear? More than 2 is a no. Yes, more than or equal to 2 is a no. Why? The reason is simple, right? Chandana, Gibbs sampling updates only one variable at a time. So you cannot change two variables. That is not possible. Right? And carefully see this, as it is mentioned over here. The first and third sequences have at most, carefully see this, at most one variable change per row. That is allowed at most, either 0 or 1. Hence could have been generated from Gibbs sampling, but in sequence 2, the evidence variable is changed. The evidence variable itself is changed, and that is not possible because we are fixing it. And in sequence 4, what is the problem? The second and third samples have both B and D changing. That's why it is not possible. Is this clear to all of you? This type of question only you can expect from the Gibbs sampling, nothing else, if they are going to ask a question from this one. And that's it. Your uncertainty module is completely over. Manjunath, you asked for that variable elimination algorithm question, right? Let me tell you one thing. In the lecture also, I told you that they are not going to ask you a question entirely on variable elimination. What they may ask is, I told you that there also in the lecture, what they may ask is, they may provide you a factor, that CPT for a factor, or maybe for two factors. And they may ask you to, to compute multiply, or to compute sum out, or to normalize this. Only these operations are possible. They are never going to ask you from end to end variable elimination algorithm implementation in a question, because you won't be having that much time in the gate exam. So that type of question is not possible. Only the operations are possible. Is that clear? And operations are very simple, right? Multiply, normalize, sum out, and there was one more. So you can see it. So only those operations, they will give you the factor table already given to you. You just have to compute that. You just have to perform that operation, and that will be your answer. So 1 mark question is possible from variable elimination algorithm. But end to end, if you remember, we have solved one question, right? At the end, that is from starting to the beginning. I mean, from beginning to the end. That type of question is not possible in the gate exam. No conditional probability value finding in Gibbs sampling. No, they are not going to ask that. That will be too complex, and that is not required for the gate exam. That much detail is not required. Clear? Any doubt, anyone? Okay, so this is over. Your uncertainty module is completely over in AI subject. I hope